In this video, I'll be demonstrating the new multi-resolution feature in the STSIM SyncroSim package. This feature is available in STSIM version 4.3 and onward, and works in SyncroSim Studio version 3.0.10 onwards. This multi-resolution feature allows you to simulate multiple resolutions of spatial data, so you can have additional levels of detail in certain areas of the landscape. In this video, we will be using an example library that can be downloaded from SyncroSim Cloud. See the video notes for more details. Let's take a look at the Definitions tab to see how the project is set up for multi-resolution. In this example, we have three primary strata that we are calling ecozones. Upland forest, which is at the base 100-meter resolution, riparian coarse, which is also at the base resolution, and riparian fine, which has a 10-meter resolution. In the state class datasheet, we have 9 state classes, and they're a combination of terrestrial and aquatic classes. These classes can be present in either the coarse or fine resolution, or in both. In this case, the soil, riffle, run, and pool classes are only present at the fine resolution. In the transition type datasheet, we have 8 transition types. Some of these transitions, like low severity fire and harvest, only occur at the coarse resolution, and others, like channel erosion and channel sedimentation, only occur at the fine resolution. Now let's take a look at the example scenario. Under the Transition Pathways tab, we have set up individual transition pathways for each ecozone with varying degrees of complexity. Let's move on to our spatial inputs. For the coarse resolution, these are found under the Initial Conditions Spatial tab. We have a separate raster for ecozone, state class, and age, all at a base 100-meter resolution. The fine resolution spatial inputs can be found under Advanced, Multi-Resolution, Initial Conditions Spatial. Here we have input the same 3 rasters, but these are at a 10-meter resolution. Each fine resolution spatial input must be evenly divisible by its corresponding base raster. Since the base resolution rasters have a resolution of 100 meters, this means that each base resolution cell contains 100 fine resolution cells. We also have a transition group resolution datasheet. This datasheet allows you to specify how the fine and base layers will interact with one another during the STSIM model run. The transition group column is where you specify the transition type or group. The resolution column is where you specify how the fine and base layers will interact. Here there are 4 options. There's base only, where the transition only occurs at the base resolution. Next we have fine only. The transition only occurs at the fine resolution. Next we have base versus fine. The transition is simulated at the base resolution and will be applied to the corresponding cells at the fine resolution. And finally we have fine versus base. Here the transition is simulated at the fine resolution and will be applied to the corresponding base cells. Whether the corresponding base cell undergoes a transition is determined by the fine versus base threshold proportion, which is this final column. If the proportion of fine cells within a base cell exceeds this threshold, then the base cell will undergo a transition. There are several advanced features that can be added at either the coarse or fine resolution. In this library, we're using the datasheets for the fine resolution, which can be found under the Multi-Resolution tab. First, we have transition spatial multipliers. These inputs specify spatially explicit multipliers to be applied against transition probabilities. Next, we have transition spatial initiation multipliers. These act like the transition spatial multipliers, except they are used to adjust the probability of a specific cell being used as the initiation location for a transition event. Let's take a look at some charts and maps from the results of this scenario. First, we can look at the state class data at the base resolution. Here we have disaggregated the results by state class and ecozone, so we can see our state class data in the riparian coarse ecozone and in the upland forest ecozone. We can also look at the same results at the fine resolution. Here we have data for each state class in the fine riparian ecozone. Now let's look at the spatial transition results. So here we have results for each of the transitions that occur at the coarse resolution, and I want to highlight the bank erosion and bank sedimentation transitions that are being forced from the fine resolution. For example, let's look at bank sedimentation. In time step 6, we have bank sedimentation occurring at these locations. And if we look at the fine resolution results, we have bank sedimentation occurring in the same locations at time step 5, since it takes a lag time of 1 time step for fine forces-based transitions to be applied. We can also look at succession and fire, because these are the two transitions that are being forced from the base resolution. Let's zoom in on time step 7 here, in the succession transition. You can see the outline of the forcing from the base resolution since they are much coarser pixels, but let's still go back to the coarse resolution. Since this is a base forces fine transition, we'll see succession occurring in those locations at the same time step. So here again, in time step 7, succession is occurring at the same location as it was in the fine resolution. Thank you for watching this tutorial on using the STSIM multi-resolution features. See the video description for more information and links to resources.